To this day, who doesn't know Starship? You probably want to know everything about the spacecraft from the number of videos you've seen on YouTube. But today I'm going to use my aerospace engineering knowledge to give a different perspective on everything you know so far. To understand each other in this video, I must repeat that Starship. The top part of the rocket, the second stage, is called the Starship. The bottom part is the first stage. It's known as super heavy, but the total combination of these two stages is also known as Starship. Remember this during the video to avoid confusion. Apart from the ambitions Elon Musk has with Starship to take human beings to Mars, it has already been confirmed that National Aeronautics and Space Administration is going to use Starship in its Artemis program to take astronauts to the moon. It has also been verified that Starship will be responsible for launching the biggest satellites for the Starlink missions. As the project advances, more ideas will surface. For example, I have already read on the internet about the possibility of using Starship to collect space debris. But with time, more ideas will surface. The problem with Starship is that it's truly difficult to visualize how immense it is. For example, the fins measure about 8 meters high. They are simply immense. There are many planes that have wings smaller than this. I, as an aerospace engineer, find this topic of fins fascinating. Many of us initially think wrongly. They had a function similar to the space shuttle's wings, but not exactly the same. The wings generated lift and were fundamental for landing, as it descended gliding and landed just like an airplane. However, in Starship, they have a control function to be able to orient the aircraft, especially in the descent process. Since, as we will go into detail now, it does so in free fall and a few meters from the ground, it needs to go vertical to land. As I've previously explained in a video, turning around was necessary, so I won't repeat myself. But in summary, in order to reuse the Starship, you can't re-enter with the engines facing down, because this damages them. Therefore, the only way left is to descend belly first, which requires changing orientation right before landing. That's what the flaps are for, to allow this maneuver, but interestingly, these flaps do not give control to the aircraft. Generating lift, aircraft control their movement by altering lift. By moving the flaps, elevator, and rudder, aerodynamic forces are generated that induce rotations in the aircraft. For example, to rotate in yaw, the plane orients the rudder. The angle of attack generates an aerodynamic force that, due to its distance from the center of mass, induces aircraft rotation. But Starship in freefall doesn't work like that, mainly because the air hits the flaps at 90 degrees. Control will be generated by orienting them more or less perpendicularly, essentially generating more or less drag to orient the aircraft. Starting from free fall, where all 4 flaps are extended. If you wanted to induce pitch movement, the front and rear flaps must move in the opposite direction. For example, to lower the nose of the rocket, the front flaps must hide and the rear ones must remain extended. This way, the nose generates less drag, lowering it. To induce the opposite nose-up movement, incomplete input. The front flaps must remain extended and hide the ones at the rear. For the roll movement, the flaps on one side remain extended while those on the other side are hidden. The uneven drag on each side causes the aircraft to turn. And finally, for the yaw, the flaps move in reverse, the front ones and the back ones. That is, hide the left front flap and the right rear one. And with these 3 combined movements, Starship can maneuver perfectly, and that's how it can flip over in the belly flop maneuver. Just before landing, where the front flaps extend completely while the rear ones hide. Everything is monitored for potential yaw or roll lateral corrections. But after performing the belly flop maneuver and having Starship already vertical with the engines on, the low speed results in practically no aerodynamic force generated by the ailerons. That's why all control just before touchdown should come from the engine gimbal for final corrections. Using ailerons allows Starship to perform a controlled free fall. Without them, it would spin uncontrollably like a cylinder. But the ailerons allow it to control this phase. Throughout 2022, Elon Musk said that in reality, with just 2 ailerons and the engine gimbal could be enough to have control over the aircraft. In this scenario, the aircraft will likely rotate slower during the belly flop maneuver. But saving 2 of the 4 ailerons would represent a gigantic leap forward. Secondly, the ailerons should be extended during re-entry to increase air contact and slow down the aircraft more effectively. This differs significantly from the space shuttle, which entered the atmosphere at an attack angle of 30-40 degrees. However, Starship must enter with 90 degrees of attack angle. because it is not an aircraft designed to fly, but it is designed to slow down by friction with the air. And then during the launch, the ailerons make the aircraft unstable. In fact, very unstable. We've discussed stability often on the channel. Check out the playlist linked above. But the summary is that if we take a plane and put its center of gravity behind the wings, as soon as there is a small disturbance that makes the plane raise its nose, the lift force on the wings will increase due to this angle having increased, which will make the plane raise its nose more, which will increase the lift on the wings more, which will make the plane raise its nose more, which will increase the lift on the wings more, which will make the plane raise its nose more, which will increase the lift on the wings more, which will make the plane's nose rise more, which will make the plane's nose rise more. Planes always have the center of gravity in front of the wings to maintain control and prevent non-stop, uncontrollable motion. If a disturbance raises the plane's nose, the increased wing lift behind the center of gravity will tend to correct the aircraft back to its initial position. Well, the Starship's ailerons during launch are like airplane wings, a bit smaller, but very, very far from the center of gravity, which makes the aircraft extremely unstable during launch. A slight disturbance would create an aerodynamic force on the ailerons, generating a significant torque due to their considerable distance from the center of gravity. The only solution is to use computer assistance that immediately after suffering disturbances, move the engine gimbals to counteract this torque. The pilot uses the controls to communicate their intentions to the computer, similar to how it works in fighter planes. And it's the computer that moves the necessary control surfaces so that the plane does what the pilot demands. Another option could be to retract the ailerons during takeoff, though they have not mentioned this yet. The Super Heavy also has grid-like fins, just like the Falcon 9 did. Recently, Tim Dodd from the Everyday Astronaut channel asked Elon Musk why they use these grid-like fins and not the ailerons. Elon stated that his top priority is to achieve orbit quickly to test the Starship's upper stage. They are aware that these fins they are using are not the best option, and they will probably end up reducing the number of these. The current design has 4, but they believe 2 would suffice, or 3 if necessary. The tower from which the rocket will be launched has been named Mechazilla, and Elon Musk said some time ago that they were not only going to use it to launch rockets, but also to collect them. When this idea first emerged a few years ago, it appeared completely insane. But today, everything is in order to start catching the Super Heavies in the air. A crazy thing? The aim is to reuse a rocket within hours, similar to airplanes, where one lands and takes off again shortly after. The way the Falcon 9 or Falcon Heavy lands requires a transport system for the first stage. Once it lands, to take it back to the launch pad, which implies several hours lost in the process. To optimize future landing times, they devised a method of catching the rocket mid-air. Initially, according to Elon, they plan to catch the rockets by the grid fins. In SpaceX's early animations, this was visible, but it was later revealed that it wouldn't be the case. They will catch it by 2 protrusions of the rocket located slightly below the fins. Catching the Super Heavy mid-air is challenging because it must be perfectly centered. If not, one leg may touch the rocket first, potentially destabilizing it. Using the tower to catch the Super Heavy means it won't need legs for ground support, as the tower's supports will hook it along the entire circumference. For the launch, the process will be as follows. The Super Heavy will arrive at the platform transported by a wheeled structure that will hook the rocket to the platform in the same manner. Once positioned next to the tower, the arms will grab the Super Heavy by the landing protrusions. 2 additional grips will stabilize it in windy conditions. Once the first stage is assembled, the same would be done with the top part of the Starship, placing it on top of the Super Heavy. The most interesting thing of all is that with Starship, the top and bottom parts are completely independent. Super Heavy and Starship join for launch, then Super Heavy returns to platform to couple with another Starship for more launches. The upper Starship continues its space mission. This was unprecedented. While Falcon 9s were being reused, they were not reused nearly as much as Starship is intended to be. As of 2022, the Super Heavy will be equipped with 33 Raptor engines. 20 of them will be in a fixed outer ring, 10 of them in a fixed inner ring, and 3 in the middle, with the ability to change orientation to steer the aircraft and correct its trajectory. Each engine generates 2,200,000 newtons, or 2.2 meganewtons. I know you don't grasp the atrocity we're discussing. An average car weighs 800 kilograms. Well, a Raptor engine will be able to lift 280 cars. The Super Heavy will be equipped with 33 Raptor engines. Here's another example to visualize it better. The Boeing 737 is one of the world's most famous airplanes that you've likely flown in. This aircraft can carry about 280 people on board. Well, a Raptor engine generates a thrust equivalent to 22 Boeing engines. Remember, the Super Heavy will be equipped with 33 of these engines. In fact, the force generated by the engines is so enormous that simply with 3 central engines, with gimbal, all the instability generated by the ailerons during takeoff could be corrected. Just by turning 1 degree each of these 3 engines, a torque would be generated in the tail equivalent to putting a Boeing 737 engine. But the Raptor engines are not the ones that generate the most thrust of the engines we know. For example, the Funo engines used in the Saturn V generated 3 times the thrust of the Raptors. Raptors are also costlier to produce than Merlin engines used in the Falcon 9 at $2 million per Raptor compared to under $1 million per Merlin. It is not the most efficient engine, with a specific impulse equal to the Space Shuttle engines. The Raptor engine is designed to be the most reusable, and this premise is the foundation of the entire aircraft's design. Re-entry is done belly first to protect the engines from damage. Methane is used as fuel since it causes less damage to the nozzle and other components. So the Raptor is the best engine that could be made to date to meet the requirements, but focusing on it being reusable. The top of Starship carries 6 engines, 3 optimized for vacuum, fixed designed to be used in space, and 3 optimized at sea level, with gimbal to do the belly flop maneuver, as discussed frequently on this channel. The nozzles aim to make the engine's output pressure the same as the pressure outside. Larger nozzles lead to greater air expansion and a more significant pressure drop. And that's why nozzles that are optimized for vacuum are very large, because you want to make the pressure as low as possible. The engine itself remains unchanged, only the nozzle geometry is modified. In Starship, Elon Musk's goal is not to design a rocket that can carry a lot of cargo into space, but to do it cost-effectively, focusing on making the price per kilogram to orbit ridiculously low. For context, putting a kilogram into orbit with the space shuttle initially cost around $85,000 over time. They reduced it to about $26,000. The Falcon 9 brought this price down to $1,800, the Falcon Heavy down to $1,000. But Starship, according to estimates, could potentially bring the price down to between $10 and $20 per kilogram. To orbit, a simply radical change. Considering that a person weighed 70 kilograms, putting them in orbit in 1981 would have cost $5,950,000. Starship will cost $1,400, resembling today's aircraft prices. The huge difference is due to SpaceX revolutionizing the manufacturing model in aerospace engineering for the first time. With the exception of SpaceX, today's manufacturers meticulously designed to ensure nothing fails. Therefore, this process takes years, as all factors must be thoroughly analyzed. SpaceX, on the contrary, has changed this design model for one of build and destroy, where the crucial aspect is to quickly develop the initial adequate prototype, test it, and literally blow it up to identify failures and determine areas for improvement. And in fact, that's why it's good that rockets explode in the first tests, because that way you can find out what made the aircraft fail, and improve that part. However, if this part doesn't fail, but is about to, it's possible that by the time you realize it, you may have to make much bigger changes in the future. The notion of launching the first prototype quickly is relative, as a rocket must be approved by the aeronautical authority, such as the FAA in the United States, before it can fly. Elon Musk has frequently criticized delays caused by authorities in giving the green light. But the important thing about these authorities is that they are independent, or at least they should be, from any company, institution, or group, and they should only be concerned with safety. That's why aviation safety should not be influenced by Elon Musk. This is the primary reason for its excellent safety record. So, according to this, it seems that the Starship program will always be limited by the FAA's timelines. Remember that what we will experience in the coming days or weeks are rehearsals. While it will take time before people can board, it's clear that it will eventually happen, and we'll all be able to experience it. It's also important to say that there are still some prototypes to be tested that, for example, are already being designed, in which Starship Superior does not have fins. It has been said that the probability of success of this first orbital test is around 50%. But don't worry, it's not a big deal if it explodes in the worst case scenario. They will have learned much from that. We return to SpaceX's philosophy of building and destroying. If the rocket explodes, they will identify the cause of failure using the numerous sensors on board, so they would realize what has failed and fix it for future versions. Therefore, even if it explodes, it's really good news. Who could have imagined just 7 years ago that we would be where we are today? And all of this is thanks to several Falcon 9s ending up destroyed, so in case this really explodes, stay calm. What Starship is achieving is going to change our lives forever, and that's why I've decided to design this Starship keychain. I designed this with love, line by line. If interested, direct message me on Instagram. Thank you very much for watching this video. See you in the next one.